Physics bonus problem 2. So, initially we're given the diagram as shown here. Now, for part A, we're asked to express the spring tension T as a function of the mass and the angles. So to unpack this question, we first need to work out what we know. We know that M2 is larger than M1 as the mass is being, M1 is being pulled over the pulley, over the mound here. So we know that this side here is going to be positive. So our F pull 2 is going to be positive. Now, we also know that there's no friction as it's given in the question. The string length is constant, it equals L, and the angles are fixed, both alpha and theta. Now, part A, we're going to go and find the net force for M1. So we're going to get our tension force of M1 here, and we're going to minus away the pull force. So our pull force to work out the net force here. Now we're then going to make MA equal to force tension force minus the pull force, and that's going to equal mass times acceleration equals T1 minus mg sine theta, and then we're going to be left with A1 is equal to T minus mg sine theta M1. Now that's our first equation here. So we're going to keep that there for later on in question B. Now mass 2, we're going to follow a similar process, except this time we know our tension force is going to be negative. So it's pushing back there rather than, and the pull force is positive as we're moving in this direction here. Now, we're going to find that A2 is equal to mg sine alpha minus tension all over M2. Now, we know that A1 is equal to A2 because it's both accelerating in the same direction, as the string length never changes. So we can let them equal each other, and now we're going to do some rearranging. And as we follow it down, we'll see the M1 times both sides by M1 and M2. And then following it through, we'll get down to T outside of M2 plus M1 is equal to M1 M2 G outside of sine alpha plus sine theta. And this will end up equaling to T equals M1 times M2 G outside of sine alpha plus sine theta all over M1 plus M2. So I've been asked to express the spring tension as a function of masses and angles. And as you can see, we've got masses, G is constant, and we've got angles here, alpha and theta. Now, for part 2, we're asked to determine the condition for which masses are at rest or in uniform motion. So, masses are at rest in uniform motion when our acceleration is equal to 0 according to Newton's first law. So, in his law, when an object is at rest, acceleration equals 0 and velocity equals 0. Now, for uniform motion, our acceleration is still equal to 0, but our velocity is constant because that acceleration is 0. So, therefore, we can take 1 and 2, our equation 1 and 2, and let them equal 0 as they're both acceleration. So, upon doing that, we can then rearrange them and let t equal the mg sine theta and t equal m2g sine theta. And since our tension forces are equal, our force of tension is equal as both are being pulled with the same amount of force, we find that T is equal, we find mg sine theta is equal to m1, g sine theta is equal to m2 g sine alpha. And cancelling out the g's by dividing each side by g, we'll find that m1 sine theta is equal to m2 sine theta. So m1 and m2 are at uniform motion or rest when m1 sine theta equals m2 sine alpha.